So today, guys, what we're going to do is we're just going to be covering one topic, which is hemispheric specialization, and then we're just going to link that to this thing called split brain experiment. So those of you who did year 10 previous E psychology, you've already kind of learned about hemispheric specialization, you know, about what the left brain kind of specializes in and what the right hemisphere of the brain kind of specializes in. But I'm still going to go through it again because, you know, it has been a while, so I think it's better we recap this. So hemispheric specialization is this idea. We know currently that the brain has two hemispheres. Yeah, we've got a left hemisphere and a right hemisphere. Hemispheric specialization is this idea or this concept that the left hemisphere has more control over certain functions and that the right hemisphere similarly also has more control over certain functions. When we say more control, we can also say specialization. Okay, because when someone is specialized in something, it means they have a greater knowledge or a greater ability in that particular thing, right? So when we say that the left hemisphere has more control in language, what we're saying is that it is specialized in language. Okay. And the left hemisphere's main function is in language. And you can remember that because L for left and L for language, okay? And similarly, the right hemisphere also has specialized functions that are a little bit different from the left hemisphere. So the right hemisphere is more to do with your non-verbal functions. So things like, for example, creativity, things like music, appreciating music, things like being able to navigate with a map, okay? Things that are not really verbal or academic or analytical, but more so kind of based on your ability to engage in things like abstract thinking, in your ability to engage in things like creativity and all that kind of stuff. So non-verbal functions, in other words. Okay, we have to be careful here, though, when we talk about left versus right brain hemispheric specialization, because we're not saying here that the left hemisphere is the only hemisphere involved in language. We're just saying that the left hemisphere plays a bigger or plays more of a role in language than the right hemisphere. So saying that it has more control is not equal to us saying that it is the only hemisphere that controls language. So just really important to keep that in mind, especially because a lot of people, when they think of hemispheric specialization, there's been this thing that people start saying, oh, you know, I really love English, but I really hate art. And for that reason, I'm more of a left brain person. That's my personality. I'm a left brain personality. So statements like that are incorrect because, like we said, the left hemisphere is not the only hemisphere that controls language, but it plays more of a role in language than the right hemisphere. It doesn't mean that the right hemisphere plays no role at all. For example, when you're reading words on a page, your ability to look at the print of the words on that page and then being able to read those words is visual. Yeah, you visually perceive the print or the letters on the page. That is the function of the right hemisphere. Okay, visual perception or context and perception. So you can see that both hemispheres allow us to engage in any specific function. Okay, some functions, one hemisphere may play more of a role than the other hemisphere, but overall, both hemispheres do work together to allow us to complete a task like reading a book or painting a picture. Okay, so we do need to acknowledge that both do have a role, but one hemisphere sometimes plays more of a role than the other. Okay, so that is really important to mention. And what we're going to do now is I'm going to show you guys a quick video and then I'm going to jump back to this slide. So what I'm going to do is I'm just going to pause the recording while we play the video. Okay, guys, so in our first lesson, and this is going to be linked to the next topic that we're covering. In our first lesson, we talked about some of the features of the brain. And we talked about this idea that, yeah, the brain is divided into two hemispheres, the left and the right hemisphere. And we talked about there being like a bundle of nerve fibers in between the two hemispheres that allow the two hemispheres to interact with one another. And that basically allow for you know, the communication between the two hemispheres to occur. So what was the name of that bridge or that bundle of nerve fibers that connects the two hemispheres? That's the question. If anyone remembers, you can put it in the chat box. So the bundle of nerve fibers that allows the left and the right hemisphere to communicate with one another. Can anyone remember what it's called? I'll give you a clue to start you off. So it starts with the letter C. See if you can remember. We also call it like a bridge that connects the two hemispheres. Yeah, excellent. Corpus callosum. Yeah, that's the one. So corpus callosum is basically the bundle of nerve fibers or the bundle of neurons that basically connects the left and the right hemispheres together, okay, allowing us to engage in things like multitasking, allowing us to do different tasks at the same time. Basically, that's because of the presence of the corpus callosum, which allows information that's in the right hemisphere to cross over to the left, just like a bridge, and allows information in the left hemisphere to cross over to the right, just like a bridge allows you to get from one side of a city to the other side, for example. Okay, now this is really, this word or this concept or this structure is really, really important for us to understand, because in something called split brain experiments or split brain studies, people with epileptic seizures actually have this corpus callosum removed. Okay, the corpus callosum is cut or surgically removed, and that causes them to no longer have a kind of joint or combined brain, but rather to have what we call as a split brain, because you've taken out the bridge that's in the middle, you've taken out the very structure that's connected the two hemispheres. Okay, and so for that reason, the patient now has a split brain. So now we need to understand, why would we do such an evil thing of removing the corpus callosum of a person? Now, there's a specific reason for this. In fact, split brain studies or split brain surgeries are not conducted a lot today. But back in the early days of medicine, when people experienced this thing called epileptic seizures, which is where you have a seizure that starts in one part of the brain, and I'm just going to write S there, so that represents a seizure. And then basically what it used to do is it started to travel all around, it started to go all around that hemisphere. And then because of the corpus callosum, that seizure was then able to kind of spread to the next hemisphere. Okay, because it's got that bridge. The seizure has that bridge that allows it to now cross over to the next hemisphere. Okay, and then the seizure would essentially, what essentially had started in the left brain hemisphere, would then go on to affect the entire brain, obviously, because the seizure had that corpus callosum or that bridge to travel to the next hemisphere. So what surgeons and doctors and physicians thought of in the day was, what if we remove that corpus callosum? Because that corpus callosum is our main kind of culprit, or because that corpus callosum is the main reason why we have this issue of the seizures traveling from one hemisphere to the other, what if we just got rid of it, get it out of the picture, just surgically remove it? And everyone was like, wow, that's an amazing idea, let's do that. Okay, without thinking of the long-term implications and consequences of that action. So what surgeons used to do back in the day was, if someone came in and they had really bad seizures, and these seizures were not allowing them to even go to work or go to school or even just live a normal life, the doctors would then suggest that this patient would get split brain surgery. So they're going to the surgery room and they basically have the corpus callosum removed. So this structure would be removed from the brain, from the middle of the brain. And what that does is then disconnects one hemisphere from the other. So the left hemisphere is then split or disconnected from the right hemisphere. There's no longer any connection or any relationship between the two. And for that reason, the two hemispheres cannot receive information from each other anymore. Okay, in the terms of the seizure, it's obviously a good thing, because we don't want the seizure being received from one hemisphere to the other and affecting the whole brain. But in terms of other information, patients who had a split brain surgery were affected. And we're going to talk about this in terms of the split brain experiment. Okay, we'll look at an actual example of a patient as well in a video. And I'm going to show you guys what are some of the things that these split brain surgery patients could and couldn't do as a result of their removal of the corpus callosum, which was the bridge in the middle of their brain. Before we talk about that, we need to talk about the ethical issues with split brain surgery, because split brain surgery is it's pretty gruesome, right? It's pretty over the top. It's pretty extreme. In fact, today we don't use this except for like as a last resort. Like if nothing else works, no other medication works for the epileptic patient, then we go on to split brain surgery. But it's really seen as a last option. One of the reasons it's seen as a last option is because it is so invasive. Does anyone remember from last class when we were looking at the other first brain experiments? Or you can just take a guess just looking at the word. What does invasive mean? Can anyone kind of unpack that word in the chat box? What do we mean when we say something is invasive or a surgery is invasive? You can take a guess. Yeah, it means physically interfering with the brain. Okay, so physically interfering, or you're physically going in and you're disrupting or interrupting the functioning and the structure of the brain there. Okay, so that was one of the ethical issues or limitations of split brain studies, that yeah, even though they allow the seizure to stay in one brain area without spreading and affecting the whole brain, it is invasive, it is physically interfering with the brain function. And for that reason, we say that split brain surgeries and the damage that they do is irreversible. Okay, it's damage that cannot be undone. You can't just grow a new corpus callosum. Once you've removed that corpus callosum, it's gone. It's not there anymore. Okay, so it's not just going to it's not just going to regrow itself in that way, like other parts of the body can. So that's basically what split brain studies are about. So just a basic introduction. So now I'm going to show you guys some pictures, okay? And this is a person after the split brain study has been conducted or was conducted. So this guy, you can't really see an X-ray into his head there, but this guy basically has no corpus callosum. So this is him after the surgery, after the split brain surgery was completed, after his corpus callosum, or the bridge in the middle of his brain, was removed. Okay. So what they do is typically they make them do a little test. Okay. And Sperry was the name of the person. Sperry and Gazzaniga were the two people who conducted the split brain experiments. Okay. They were the ones who did a lot of research in this area of split brain studies, taking patients who have had their corpus callosum removed and testing them in all these different testing conditions. So those are the names of the people that were involved with split brain studies and split brain experiments. Anyway, so what happens is we take a person who, after the split brain study, obviously has no corpus callosum, we put them in front of a screen, okay? And then we basically project two words or two images or whatever in front of them, okay? And you can see that on this screen, you've got a left-hand side of the screen, okay? And then you've got a right-hand side of the screen. And you can see that this is divided by a little line in the middle, okay? Now, generally what happens, and in the video that we just watched as well, when something is flashed to the left-hand side of your visual field or to the left side of your line of sight, what that means is it actually ends up in the opposite brain hemisphere. Just like you guys learned maybe about last year, or if you learned in year 10, that the left side of the brain controls the right-hand side of the body, yeah? And the right-hand side of the brain controls the left-hand side of the body. That's what we call as contralateral functioning. It's basically this idea that the opposite side of the brain controls the opposite side of the body there. Okay, so that's contralateral functioning. Now, if something is flashed to the left visual field, what we usually say is that it will end up in the right brain hemisphere. So this guy reads the word egg, and that is basically ending up in his right brain hemisphere. Okay, so I'll just put left and right at the bottom here as well, so it's easy for us to see. So this is the left, and then this is the right brain hemisphere. Okay, so when you put something in the right visual field, okay, that's going to end up in the left hemisphere. So you can see that color coded, that red goes to the left brain hemisphere of the person. Now, can anyone remember which brain hemisphere did we say plays more of a role in language? Was it the left or was it the right? Yeah, left. Remember we said alpha left, alpha language. So language is a more specialized function of the left hemisphere compared to the right hemisphere. So that's why, guys, when this split brain patient who's got no corpus callosum anymore, when he sees the word spoon in the right visual field or on the right hand side of the screen, and it ends up in his left hemisphere, he's able to easily say the word spoon, because the left hemisphere plays more of a role in language as in reading, writing, speaking, all the different elements of language. That's why he can say the word spoon. However, when he reads the word egg, that's on the left-hand side of the screen, that ends up in the right hemisphere. We say that the right hemisphere does play a minor role in language, but not actually in terms of speaking. Okay, speaking is a specialized function of the left hemisphere. Now, in a normal person, how this would look like is that we read the word egg, like me, I've got my corpus callosum intact. I read the word egg, it's on the left-hand side of the screen. It ends up in my right hemisphere, but it can't be verbalized or spoken because the right hemisphere is not specialized in language. But because I've got the corpus callosum, that word egg, which I will write here, okay, will actually travel across the bridge that's the corpus callosum to the left hemisphere. And now, just like the word spoon, this split brain patient is now able to say egg, that word is egg. But when that word egg is in the right hemisphere, it cannot be verbalized, okay? Because this split brain patient doesn't have a corpus callosum, the word egg cannot cross over to the left hemisphere, okay? And it just stays in that right hemisphere and is not able to be verbalized. That's why this guy can't say the word egg. He can't say that that word that's on the left-hand side of the screen is egg. So he can't actually verbalize that, because the right hemisphere does not play a major role or does not have a major specialization in language. Okay, this is actually probably one of the most confusing topics in Unit 1 psychology. In fact, this used to be, a few years back, this used to be in Year 12 psychology as a topic, and then they moved it back down to Year 11. So this is actually a confusing topic. So if it doesn't make sense straight away, don't stress too much, but we will go through another example as well. Okay, but this is the basic idea. If something is flashed to the left-hand side of the screen or to the left visual field, it will end up in the right hemisphere and the person will not be able to say the word that's there. However, if it's flashed in the right visual field, it ends up directly in the left hemisphere, which we said plays a major role in language. And so the person can say the word. Okay, so that's the basic idea. So that's just a really quick introduction into what kind of split brain studies are conducted, or what basically is conducted in the split brain experiment. How do they test what the person with a split brain can and can't do? Okay, so here's another example. This is the full explanation of everything I just said before. So this is literally all we really expect you guys to be able to understand. We're not going to ask you to give a bigger analysis than this, in other words. Okay, so you can see similarly here, guys, when you've got the screen again, you've got two different things on the side of the screen. So you've got your left side of the screen here. Okay, and this is your right side of the screen. And then corresponding to that, you've got your left brain hemisphere. I'm going to write L, and then you've got your right brain hemisphere. So you can see when the word ring occurs in the right visual field or is flashed to the right hand side of the screen, that will end up in the opposite brain hemisphere. You can see that ends up in the left brain hemisphere. We know the left brain hemisphere has a role in language, a specialized role. So you can see the guy saying the word ring. He can say that because it ended up in the left brain hemisphere. However, he can't say the word key. Okay, the reason he can't say the word key is because it's in the left visual field, or it's flashed to the left hand side of the screen. It ends up in the opposite brain hemisphere. So in other words, this is going to end up in the right brain hemisphere. Because the right brain hemisphere doesn't play a major role in language and speech, he's not able to say the word key, but he can still prove to the experimenter that he knows what the word is by picking up the key with his left hand. Now, why is he picking it up with his left hand? Let's go through this. Because the word key is flashed in the left visual field, it ends up in the right brain hemisphere. Now, based on the concept of contralateral functioning, if something ends up in the right brain, which part of the body does the right brain hemisphere control? Is it the left-hand side or the right-hand side? So if a word ends up in the right hemisphere of the brain, the right hemisphere of the brain is specialized for movement on which side of the body? Is it the left-hand side or the right-hand side? Yeah, correct. Left-hand side. Excellent. So we say that whichever part of the brain hemisphere, whether it's the left or the right, usually controls the opposite side of the body. So because the word key, we can see here, is currently in the right brain hemisphere, it can't cross over to the left hemisphere. There's no corpus callosum there. So the right brain hemisphere controls movement on the left side of the body. So he can be like, okay, Mr. Experimenter, I know what that word is. I can't say it, but I know that that's key. I can prove to you that I know it by picking up the key from behind the screen with my left hand. And that will prove to the experimenter that this guy still has a good recognition of objects. It's just that he's not able to say the word key. Okay, so this is basically the patient's ability to prove that they still can understand what word is there. They just can't speak in order to say it, or they just can't say what they saw. Okay, and that's because the left hemisphere has a bigger role in speech and language than the right hemisphere does. So that's the basic idea, guys. And just to summarize, what was the point of the whole split brain studies? The split brain studies and the split brain experiments that Sperry and Gazzaniga conducted were basically trying to prove evidence or provide some kind of research kind of evidence there about the fact that the two brain hemispheres are specialized for certain functions. So this kind of proved the idea of hemispheric specialization. And it also kind of supported this idea that the corpus callosum is a bridge. And it's a very important bridge because it allows for the exchanging of information between the two hemispheres, and that if that bridge is then damaged, or if that bridge is then severed, or if that bridge is surgically removed, as we see with split brain patients, then the two hemispheres can no longer exchange information, and that the patient will then be limited in terms of what they can do. So they can only say a word if it ends up on the right visual field, on the right hand side of the screen, but they can't actually say that same word if it ends up on the left hand side of the screen. So that's something to just basically what the study was about and what was the purpose and the main kind of what we learned from the study, basically. Okay, so let me just clear all the drawings. And this is just another example, just taken from one of our old textbooks. So you can see here that when you've got a pencil that's, when you've got a pencil on the left-hand side of the screen, and it's flashed obviously to the right visual field because it's on the left-hand side, so it goes to the right visual field. The patient knows that this is a pencil, but they can't say that I saw a pencil, okay, because the left hemisphere is more involved with speech, but they can still pick up that pencil and prove to the experimenter that that's what they saw, or that's what they recognized. Now, if we then flip that pencil to the right-hand side of the screen, so here it was originally on the left, and it's still on the left here. The patient is able to pick up that pencil. Pencil ends up in the right hemisphere. They're able to then pick it up with their left hand. You can see here, just like in the previous example. Now, if the experimenter says, okay, let me switch up the position of the pencil, let me move the pencil to the right-hand side of the screen or to the right visual field. Now you can see that the pencil will end up in the left hemisphere. And because the left hemisphere is specialized in language, now you can see that the patient is able to use their language abilities and use their speech abilities to say, I saw a pencil. So because it's ended up in the left brain hemisphere. Okay, so depending on where the item is flashed, whether it's on the left or right hand side, that patient will be able to either pick it up with their left hand, or will be able to clearly say that I saw that pencil, or that is a pencil. Okay, so that's just another example just to show you guys. Now, I know this is a bit confusing, but as long as you understand which function each hemisphere is involved in, and basically the fact that when something is flashed to the left-hand side, it goes to the opposite side of the brain and vice versa, that will basically be your main things that you need to know in order to understand this topic. Okay, but I do acknowledge that it's a difficult topic. So if you're finding it a bit confusing, it's totally normal. Alrighty, so that basically covers the split brain hemispheric specialization and split brain studies for us. So what I want to do now is I want us to just work on the questions together. We still have about 20 minutes. And it's not a lot of questions. So if everyone can open up their worksheet booklet, this one, we can just finish off activity 9 and activity 10, and that will mean that you don't have any extra homework. So if you can just upload that once we're done for today, then you have no extra holiday homework on top of that. Okay, guys, so I'll just give you like a minute to quickly, get your workbook opened up. And then we're starting with activity 9. Okay, the first question is pretty easy. Name the brain structure that joins the two hemispheres as shown in the image above. So who can tell me what is that brain structure that the red arrow is pointing to? Corpus callosum, excellent. Okay, so we're just going to type that here, corpus callosum. Yeah, and guys, as we're doing these questions, it'll be a really good idea for you guys to also type this in as we go. So it means less work for you later on. Okay, now, can anyone describe, and you can use your PowerPoint as well to answer the next question, but can you describe the role, the key role or the function? What is the main function of the corpus callosum? We said that it acts like something, so you can say it acts like which one is that? What's ILP again? What do you mean by ILP? I'm not sure. You might need to clarify that question. I'm not sure what you mean. Oh, okay, no worries, no worries. So activity, yep. So when we're looking at the next part of the question, describe the key role or the function of the brain structure. So what is the key role or function of the corpus callosum? What do we think, guys? When we're talking about the key role or the function, what would we say? What role does the corpus callosum have? Yep, it connects the two hemispheres. Excellent. So we can say that the corpus callosum, and I always like to talk about the fact that the corpus callosum acts as a bridge. Okay, so the corpus callosum is a bundle of nerve fibers. Because when you think of it as a bridge, it makes it easier for you to then further explain what its purpose is, and that is to connect the two hemispheres, which connects the two brain hemispheres and allows them to communicate with one another. That's the answer there. So I'm just going to put that in bold so it's a bit easier to see. Okay, awesome. So let's move on to the next question. I'm just going to move this up. Okay, the next one is pretty easy. Can anyone name 4 specialized functions of the left brain hemisphere? So you find them on the PowerPoint slide itself. And if you remember from year 10 previous CE Psych as well, if you've done that, you might remember some of the functions. So what's the first one we can talk about? Remember, we can break down language into a few separate functions as well, talking about all the different aspects of language. So left brain hemisphere, what functions might we include? What could we say? We can say reading. Yep. What else? Yep. Speech, writing. Yep. So we definitely saw how important the left hemisphere was for speech in the split brain experiments. Writing, analytical functions. Yeah, good. So analytical functions are things like when you're analyzing, for example, mathematical ability. Okay. Or when you're analyzing a text, for example. Yeah, you can also talk about, I'll just add that one too. That's a good one. Sensory and motor control on the right-hand side of the body. Because remember we said the left brain hemisphere controls the right-hand side of the body and the right brain hemisphere controls the left-hand side of the body. So that's good. And we can actually transfer this one across to to this page as well, or to this part of the right brain hemisphere, and just change this to left. That's a good one too. All right, now we've only got 3 more to go for right brain hemisphere. So can anyone tell me 3 other functions or 3 other specialized functions of the right brain hemisphere that we could discuss? Remembering that the right brain hemisphere plays a big role in non-verbal functions. Creativity? Yeah, excellent. So creativity. What else can we talk about? Yep, music. Appreciation of music, appreciation of art, spatial awareness. Yep, perception as well. So making judgments of things. For example, when you're about to cross the road and you see a car coming and you're like, okay, I don't think I can make it. I'm not going to be able to cross in time. That's because of your right brain hemisphere, which allows you to engage in that non-verbal function and make that spatial judgment there. So yeah, good answers, everyone. Okay, awesome. So I'll leave that for a few seconds more and then we'll go to the next question. Okay, hopefully you guys have got that down. Even if you haven't, it's okay, because when I put the recording up, you can go back and check. So what I'll do is I'm just going to go down to the next activity, which is our last activity for today, looking at the split brain study. So I've got an example here similar to the pictures we had in the slides. So it says, using your knowledge of Sperry and Gazzaniga split brain studies, analyze each image below, which shows a split brain patient's responses for when the word face is flashed onto the left and right hand side of the screen, or in other words, the left and right visual fields. And then you're going to answer the 3 questions below. So you've got those images there. So this is an easy question. We've done this many times today, but what is the name of the structure that we remove in split brain patients that causes them to have the split brain? Yep, it's the corpus callosum. Correct. That's why you had two little blanks there. So we're going to very important word because it is a key word there as well. Good. Okay, so the next part, describe the function of the structure. Well, this is just repetitive now. So I think we're just going to go up and we're just going to copy paste our answer from the previous one because there's nothing extra we need to add to this one. So I'm just going to copy and I'm going to paste it here. And you can do the same. Okay, so that's pretty straightforward. Now, I'm going to maybe make these a little smaller so that we can have them all on one page. Okay. Okay, cool. So now that we've got the part C, so why is the split brain patient able to say the word face when it is flashed onto the right-hand side of the screen? Explain your answer with reference to what you know about hemispheric specialization. So can anyone give me an explanation why is the split brain patient able to say the word face when it's on the right-hand side of the screen here, but not when it's on the left-hand side? So I'll give you like a minute because you might need to give a little bit of explanation here, but just explain why. Think about the hemispheric specialization and which part of the brain is involved or specialized in language. Okay, so just give me maybe a sentence long answer should be enough for this part C of this question. So remember the word face is on the it's on the right-hand side of the screen. Okay, where is it going to end up? It's going to end up in the left hemisphere. So that's going to be the first part of your answer. And then you're going to explain what then happens when the word face ends up in the left hemisphere. Okay, so think about what the left hemisphere is specialized in terms of what function it has a lot of control over. Okay, anyone got an answer for that yet? Okay, so we can start by saying that when the word face is flashed onto the right-hand side of the screen, it will end up in the left brain hemisphere. So that's the first thing that you would include. Then you would say, because the left hemisphere is specialized in language, specifically speech in this case, the split brain patient is able to verbalize or say the word face. That's it. Okay, that's the answer there. So that's what you would include. Okay, RHS means right-hand side of the screen. Okay, any confusions about part C? If it is, just let me know. I can explain why the answer would be this or why the person would be able to say the word face. It's just similar to the examples we've looked at in the PowerPoint. Okay, you can see when the word face is written, is on the left-hand side of the screen. Okay, in contrast to the first example, when it's on the left-hand side of the screen, it ends up in the right hemisphere. So the patient will say, I saw nothing, because the right hemisphere is not specialized in speech and language, but the patient is still able to prove to the experimenter that they know what the word is in their brain, even though they can't say it, by drawing a picture of what the word is, or drawing a picture that represents the word with their left hand. Okay, we know that it's the left hand because the word face has ended up in the right hemisphere, and the right hemisphere controls movements on the left-hand side of the body. That's why the guy uses the left hand to draw the picture of the face. And we know things like creativity are also specialized in the right hemisphere, which is why the person is easily able to draw the face, but is unable to say the word face. Okay, so that's the basic analysis of those two images there. Okay, I think we just have one more question to do. And I think I've just covered that in my explanation as well. Okay, so why does the split brain patient not say the word face when it is flashed to the left-hand side of the screen? What do they do instead to prove that they know the word on the screen is face? So we've just talked about that already. Okay, we've talked about this idea. If I can zoom it out a little bit, we talked about this idea that when the word face is flashed to the left-hand side on the LHS of the screen, it will end up in the right brain hemisphere. Because the right hemisphere is not specialized in language and speech, the patient will say that they can't see, or the patient will say nothing. Okay. However, the right brain hemisphere can allow them to move their left hand to draw a picture of what they saw, which is a face. So that is basically the explanation for that one. Okay, so that's what you can talk about when you're talking about nothing. Sorry, I'll just add one more thing. As there is no corpus callosum, send the word to the left hemisphere. Sorry, spoken or verbalized. Okay, so that is kind of your explanation for the second image there. I'll just make this a little bit bigger so everyone can see. Okay, so that basically finishes up activity 10 answers. Now, are there any questions, guys, from activity 9 or 10 that didn't make sense to you, or you'd like me to explain it a little bit more? Or any part of those split brain images that didn't make sense or were confusing? No? Okay, I'll give you guys anyway, like maybe 30 to 45 seconds to finish typing up these answers. Okay, and once you guys finish typing up these answers, we're not expecting you to complete activity 11 and 12 before submitting, so you can just submit up to activity 10. And when we get back to school next year, inshallah, we'll focus, we'll start from neuroimaging, and then we'll finish those activities within class next year. If you'd like to go ahead and you'd like to give it a go, by all means, you can do that, and you can just email me your work. But we do want you guys to have a bit of a relaxing holiday, especially after this year, which has been quite a stressful year. Okay, so yeah, if you have copied all the answers, that's amazing, that's really good. What I need you guys to do is please upload this right now before recess, so you've still got about 5 minutes. Just upload this onto the school box. There's a due work there, so make sure you upload this so that I can tick you off and say that you've completed all your work for the transition week. Okay, so that's it, guys. So enjoy the rest of your, oh yeah, today's the last day. So enjoy your holidays, and I will see you guys next year, inshallah. And take care and have a safe and a nice holiday. Bye-bye.